Good afternoon. Welcome to the 21st Annual Geddes W. Simpson Lecture, and welcome to Buchanan Alumni House. My name is Sarah McPartland Good, and I'm the General Counsel of the University of Maine Foundation, whose office is upstairs. Professor Geddes W. Simpson was a distinguished researcher and teacher at the University of Maine. And back in 2001, his family came to the foundation looking for a way to honor his memory. And the foundation specializes in creating lasting legacies through endowed funds. So the Simpson family decided to create a fund which would support a lecture, which is given by an individual who has provided significant insight into the area where science and history intersect. So I want to welcome all of you here today and to especially recognize the Dean of the College of Liberal Arts and Sciences, Emily Haddad, and the Dean of the College of Natural Sciences, Forestry, and Agriculture, Diane Rowland, who are with us today. Both colleges play an important role in the lecture every year. I also want to recognize that we're very fortunate to have four members of the Simpson family with us today. Geddes and Carol and Bob and Diana are here with us. So thank you very much for creating this lecture. And I think we have at least one and maybe two other members of the Simpson family with us virtually. And speaking of virtually, I know we have Barbara Cole's chemistry class is with us virtually, so I'm grateful to all of them for being with us too. So Mark Anderson is the chair of the Simpson Lecture Committee this year, and I want to thank Mark. Where are you, Mark? Over there. Thank you, Mark, for all your hard work to make this happen. Jeff Mills, who is the president CEO of the foundation, is also with us. There he is. Mark McLaughlin, who is the Assistant Professor of History and Canadian Studies, is now going to introduce our speaker. Thank you for coming.
Good afternoon, everyone. It's so nice to see so many people here. Nice to see some of the local royalty in attendance as well. Joking. Thank you, everyone. As I mentioned, or as was mentioned, my name is Mark McLaughlin. I'm an assistant professor of History and Canadian Studies here at the University of Maine, and it is my pleasure to introduce Dr. Stephen Bocking. Stephen Bocking is Professor Emeritus in the Trent School of the Environment at Trent University in Peterborough, Ontario, which is about an hour and a half northeast of Toronto, where he served as professor and for a time as chair and director of the School of the Environment from 1994 to 2022. Originally trained in biology and the history of science, his research interests encompass the historical and contemporary roles of knowledge in environmental affairs. He is the author of about 60 articles and book chapters, making me feel bad, and the author or editor of more than a few books, including Ecologists and Environmental Politics, A History of Contemporary Ecology, Biodiversity in Canada, Ecology, Ideas and Actions, Nature's Experts, Science, Politics and the Environment, Ice Blink, Navigating Northern Environmental History, and Cold Science, Environmental Knowledge in the North American Arctic during the Cold War. So you can see he has quite a nice breadth of background there. More personally, I'm very glad to see Stephen here. He was my postdoc supervisor back in 2014-15, so it's fantastic to see him in this space. And when I first went to Peterborough from New Brunswick for my postdoc, in my PhD, whenever my supervisor wanted to have a meeting, he'd say, let's have a pint at the grad club and we'll talk about your chapter. When I moved to Peterborough and I had my first meeting with Stephen, he said, I walk the trails every day, come join me and let's talk and walk. So I knew it was gonna be a very different experience, but a very enjoyable one nonetheless. And I'm also here representing Dr. David Hart, who co-nominated the director of the Mitchell Center, who co-nominated Stephen to be with us here today. And I know that one of Stephen's books was important in terms of inspiring, helping to inspire the founding of the Mitchell Center for Sustainability Solutions, 2004 or so, so quite a while ago. And related to that, I was mentioning to my wife that Stephen was coming. And I said, oh, we want to have him over for dinner. And she's, oh, that'd be great, because she met Stephen a few times. And, we get a CSA veggie box, and we had this cabbage that's just been sitting in our fridge, because what do you do with cabbage? So she said, well, we were planning on having cabbage soup, so let's have cabbage soup. I was like, great, and that's be a nice meal, and we'll have Stephen over. It's a great soup. And when I sort of was talking to her that Stephen was coming, and I mentioned that he was sort of inspired the Mitchell Center and different things, she said, Mark, Stephen's kind of a big deal. We can't feed him cabbage soup. But there was also lentils and sweet potatoes, and he went back for a second bowl, so it couldn't have been terrible. But anyway, without any more delay, Dr. Stephen Bakke.
Okay. Let's do that. Just have to get the technology here. I think I'm here. Share. Right. Are we here now? Yes, good. Okay, thanks, Joe. All right, well, thank you, Mark, for that lovely introduction. And for the record, that cabbage soup was wonderful. Absolutely, as were the biscuits that went along with it. Thank you so much to the Simpson family for your generosity in hosting this talk or making it possible for me to be here today. Had a really interesting morning already at the University of Maine. I'm just enjoying your beautiful campus and looking forward to the story of the rainstorm, which is apparently arriving at some point tomorrow. So looking forward to seeing the campus in a different kind of light tomorrow as well. So I've had a really interesting time here, and I appreciate the hospitality that I've experienced from everyone so far today. And I hope you find my talk as interesting over the next hour or so as I found my visit so far. So what I'm going to be talking about today are some ideas about the Arctic, and they stem especially from my quite long-term interest in the historical relationship between science and environmental affairs. We take as a basic kind of principle of environmental politics, environmental science, that science is absolutely crucial as a source of guidance, a source of information when it comes to solving the challenges that arise in our relationship with the natural environment. So that's kind of been a major research interest of mine. I've looked at that in a variety of contexts, looking at it in terms of natural resource management, the urban environment, particular industries such as salmon farming. And a number of years ago as well, I started getting really interested in Arctic science and the evolving roles of science in Arctic environmental affairs. There's a variety of ways in which science has played roles in understanding the Arctic. There are certainly a whole range of critical environmental challenges that are experienced in the Arctic as a result of energy exploitation and natural resource exploitation generally, trying to understand the consequences of global environmental change for the Arctic. And there is also just a rich history of scientific research in the Arctic, going right back to the era of exploration. But as I studied the history of Arctic science, I also found my ideas about science challenged in fundamental ways. My original training was as an historian of science. So I saw science as really central to our ways of knowing the world. But as I studied Arctic science and Arctic knowledge more generally, I started to realize how to define the relevant knowledge of the Arctic simply in terms of science was really hopelessly kind of naive and really excessively narrow, that there are so many ways of understanding the Arctic that are current amongst us today. There's a long history of natural history study, of people basing their understanding of the Arctic simply on the basis of their economic activities of fur trapping, hunting, and so forth. And above all, there is an incredibly rich history of indigenous knowledge about the Arctic as well. The fact that people have lived there for hundreds and hundreds of years, have lived in, experienced, hunted in, eaten the products of the Arctic landscape and seascapes. And that is an incredibly rich body of knowledge that's been passed down from generation to generation. And so it really kind of experience in studying Arctic science has taught me that I need to reconsider my ideas about science and about knowledge more generally. And so that has been an important kind of personal education when it comes to studying Arctic knowledge, just about broadening our ideas about what actually counts as knowledge about the world. And then as well, over the last few years, as I've been thinking further about how to think about the history of Arctic science and Arctic knowledge, I've really come to understand that a major focus of understanding the history of Arctic knowledge has to be understanding the place of the Arctic in the world. Well, one thing that has become increasingly apparent over the last few years as concerns about global climate change and global environmental change have become so prominent in daily politics and daily society is that the Arctic is so often featured in discussions about the global environment, even amongst folks who may have never visited the Arctic, who may live thousands of miles from the Arctic, and so who have no daily knowledge of what the Arctic actually feels like as an environment. Nevertheless, the Arctic is very often invoked as crucial to our understanding of the global environment. One experience I had that really kind of brought home to me how this is kind of, there's something happening here that's significant, is actually when I was in all places on a subway train in the middle of Tokyo a number of years ago when I was in Tokyo to give a couple of talks. And this is a few years ago, pre-pandemic, obviously. But there's a poster in the subway car in the Tokyo subway system advertising that they're bringing out new green, highly environmentally friendly subway trains for the Tokyo subway system. And the way they communicated that these were really green, environmentally friendly trains was that they had a cartoon representation of a subway car and all the passengers were a whole bunch of really happy polar bears. And it struck me how, Tokyo, a city of 35 million people, 10 times as many people live there as live across the entire circumpolar Arctic. It's about as far in conceptual and mental terms as you can get from the Arctic. And yet the folks in the Tokyo subway system thought that we want to communicate greenness and environmental friendliness, let's invoke polar bears. So I thought, why is that? What is going on here? And this is something that we see more generally in our understanding of the Arctic that's certainly apparent in media presentations of the Arctic. So a few examples of this. Considering how the Arctic today is presented in popular media as a global space. A few examples on magazine covers, for example, that talk about the vanishing north, the idea that the Arctic that we were once familiar with is disappearing and is being replaced by something else. Or again, in the National Geographic, the Arctic is heating up, that there's transformative change happening. You can see this in a whole array of practically a library of books that have appeared in recent years, talking about aspects of the Arctic as a region in transformation. Silent Snow, for example, talking about contaminants in the Arctic, invoking obviously Silent Spring of 50 years previously. Or Brave New Arctic, the untold story of the melting north, written by a prominent climate scientist, again, talking about there being a brave new Arctic, somehow replacing the Arctic that we already thought we knew. Or again, The Earth is Faster Now, compilations of indigenous observations of environmental change in the Arctic. Again, capturing this idea that something fundamental is happening in the region. Again, as well, the idea that the Arctic is becoming kind of a central, almost battleground of the conflict between environmental protection and natural resource exploitation. In this case, about the concerns about the prospect of oil drilling in the Arctic National Wildlife Refuge. My magic. Finds Dunaway actually is an American scholar who is now a colleague of mine at Trent University. And so we're very proud of his work. After the ice, again, life, death, and geopolitics in the new Arctic. Again, presenting a polar bear adrift on a small iceberg as emblematic of wondering what is going to happen as the ice disappears. The notion of a scramble for the poles, which has been often invoked in recent years. The idea that as the Arctic is transformed, as the ice melts, that's going to lead to a scramble, a struggle for power among the various circumpolar nations for resources and for access and even control over the Arctic region. So there's a variety of ways in which the Arctic has really become, to some extent, kind of front and center of discussions about the global environment, become a matter of pressing concern, even amongst many people who may not have direct experience or knowledge or even been near the Arctic. This is kind of a striking example that appeared in the COP26 United Nations Climate Change Conference just last fall in Glasgow, where this is the exhibit presented by the Tuvalu nation of the South Pacific, in the South Pacific. Again, it was striking to me how the people of Tuvalu decided to represent themselves. You know, they're in a small island. They are one of those endangered South Pacific islands. The highest point of land in Tuvalu is 4.6 meters above sea level. They face an existential danger from global sea level rise, that their nation may become literally under the water. And yet again, they presented themselves in terms of this rather poignant image of a number of polar bears on a disappearing ice floe, all wearing life jackets. So again, it made me wonder, what is going on here that even folks coming from a South Pacific island, you know, palm trees and 12 months of summer and all that, that they saw polar bears as a useful kind of ambassador for their concerns. It made me wonder, what is going on here? So what we have to think about, why has the Arctic being so often invoked as kind of a symbol or a metonym of the changing Arctic, changing global environment? We might think of this in terms of the various images that are available that capture aspects of global change in the Arctic. Consider, for example, you know, pictures that are familiar to many of us, glaciers calving as icebergs as they encounter the seashore, you know, providing dramatic images of large-scale glacier melting. Or again, images of melting permafrost, you know, frozen ground that's often been immobile for thousands of years, but now is to some extent disappearing between our eyes and even eroding into the ocean, as here on the north slope of Alaska. Or again, the significance of migrating caribou, one of the iconic species of the North, with the sense that they are also facing existential dangers as a result of energy exploitation in the Arctic and of the prospect of large-scale environmental change as a result of global warming, among other things, as the nature of the tundra on which the caribou depend changes over time. Or as another example, just noting this already, the iconic significance of polar bears as a symbol of the changing Arctic. With the idea, as often presented by environmental organizations concerned with Arctic environmental affairs, the idea of polar bears as the most compelling ambassadors of Arctic environmental change. Polar bears, especially when presented as part of a small family group, usually of a polar bear mother and 1 or 2 or 3 cubs, with the implicit message that that we have ourselves, the target audience for this environmental organization, we have responsibility for these polar bears and their well-being, because without you, there is no them. So this idea then of what we may be thinking of is instances in which compelling images may be driving this changing sense of the significance of the Arctic in global environmental affairs. We can also note how these images are backed up by a considerable body of scientific research. There's a great deal of research that has been carried on over the last few decades on the changing Arctic environment. For example, work by prominent polar bear biologists such as Ian Sterling, portrayed here, who worked for several decades for the Canadian Wildlife Service, becoming one of the world's leading experts on polar bears and providing kind of the scientific substance behind these images of endangered polar bears. Again, field parties that are in ever expanding numbers heading out into the Arctic Ocean to map and track the trends and dynamics of Arctic sea ice. As well, the avalanche, no pun intended, of reports on the changing Arctic environment, of the presence of contaminants, often that have traveled from far distant sources to contaminate the North in various ways. And so trying to get a handle on the significance of pollution in this region that was once considered more or less pristine. As well, the emergence, as represented, for example, in this report published by the Intergovernmental Panel on Climate Change, the emergence of this concept of the cryosphere, the part of the globe that is dominated by snow and ice, basically acknowledging that there is a distinct kind of environmental science and environmental thought that is associated with snowy and icy environments that have to be applied in order to understand the Arctic Ocean and the Arctic landscape generally. So there's a substantial body of research that we could also perhaps invoke as to help us understand why the Arctic has become so central to concerns about the state of the global environment. That in short, this combination of images of a disrupted Arctic, and on the other hand, this accumulating body of scientific research that have together kind of instructed us to have concern about the Arctic in its global context. Certainly, a great deal of knowledge has accumulated, scientific knowledge has accumulated to demonstrate why and how the Arctic is changing, often so rapidly before our eyes. Classic images that become widely familiar, illustrating how the Arctic is warming faster than practically any other place on the planet. The deep orange going to red to purple is those are zones where the temperature has increased most rapidly since the baseline date of the late 1970s. So indicating clearly how the Arctic is warming much more rapidly than practically anywhere else on the planet, and how this is understood as part of the phenomenon known as Arctic amplification. The idea that the warming that is happening across the globe is amplified in the Arctic in various ways that have to do with the nature of the Arctic physical environment. The basic storyline is that as the Arctic warms up, Arctic sea ice melts, more of the Arctic Ocean is exposed. The ocean is darker than the white sea ice. So as being darker, it absorbs more heat, gets warmer faster, and that creates a positive feedback. That greater warmth in the exposed Arctic Ocean then melts more sea ice, exposing more ocean, and around the cycle continues, resulting in trends that have become quite familiar today to climate scientists of a more or less steady, episodic, but more or less steady decline in Arctic sea ice each winter. Then as well, observations, not least by the climate scientists here at the University of Maine, have observed how the changing temperature regimes in the Arctic is resulting in changing weather patterns on a hemispheric scale, as the polar vortex that defines so much of the Arctic weather and weather really of the Northern Hemisphere, as it erodes, as the great difference between cold Arctic and temperate regions declines, as that great as the two areas become somewhat closer in temperature, then the division between Arctic weather and temperate weather erodes as well, causing all kinds of disruption to the polar vortex, to jet streams and so forth, causing really strange weather patterns, not necessarily just in the Arctic, but in much of the rest of the Northern Hemisphere as well. So as is becoming increasingly visible in the news media, that increasingly it's being understood that if we want to understand unusual phenomena such as freezing weather in Texas last winter, or current drought and heat, or just over the most previous summer, summer of 2022, then we need to trace what has been happening in environments closer to where we live in terms of what's been happening in the Arctic. Less sea ice and more snow are pushing, in this case, cold extremes to eastern North America, or causing disruption of summer weather patterns in temperate regions as well. And then as well, the global consequences of warming in the Arctic and also in the Antarctic, melting of the Greenland ice cap and the Antarctic ice cap being a major contributing factor to the overall progressive rise in sea level that's been observed over the last few decades. Then as well, how scientists are gaining an increasing understanding of the significance of the Arctic in the future, not just in the past, but in the future, to a changing global environment, with the prospect of melting permafrost becoming a globally significant source of carbon and methane, which will have consequences for the global atmosphere, accelerating and amplifying global greenhouse effect. And then again, with just recent observations, such as reported in the paper just a couple of months ago, about how Arctic warming has been observed to be happening in an amplified way more quickly in recent years. And it seems to be happening even faster than certainly climate models have predicted, and that recent observations have suggested that it may be warming as much as 4 times faster than the rest of the planet. So if I have not all discouraged you so much already, but the basic idea here is that if we want to understand this basic phenomenon that I began with, then, of the Arctic being seen as a globally significant environment, not just of interest to folks who live in the Arctic themselves or have a scholarly or a scientific interest in the Arctic, but as something that matters globally, that what happens to polar bears perhaps happens to us, that perhaps we can explain this in terms of, as I said, these compelling images of a disrupted Arctic, with images, single image will tell us a whole story, single picture's worth 1,000 words, and all the rest of it. And then also the increasing body of scientific research showing how the Arctic really matters as an environment. So that's a hypothesis we can perhaps start with, that we care about the Arctic because the science tells us to. Okay. We can continue this by noting how not just the Arctic physical environment, but the Arctic ecological environment is changing as well. Many species are migrating northwards, and there's becoming a significant issue with invasive species moving north from year to year from temperate regions, becoming present in the Arctic and basically having a fundamental impact on Arctic ecosystems. Orcas, for example, killer whales, migrating further north each year and becoming perhaps the most significant predator eventually in the Arctic Ocean, much to the discomfort of seals and walruses and beluga whales, as well as almost uncanny, almost disturbing images of ecological change as well. As portrayed, for example, on the front cover of the Arctic Journal a few years ago, the individual here, it's an instance of what has been observed in recent years of hybridization between grizzly bears and polar bears. As grizzly bears, as warming has moved further north, grizzly bears have moved north with the warming weather and sometimes into the territory occupied by polar bears. And in the natural order of things, grizzly bears and polar bears have hybridized and produced kind of hybrid species that is somehow a combination genetically of grizzly bears and polar bears, so almost with a new kind of bear with 2 paws in the Arctic and 2 paws in more temperate regions, creating a bear that looks sort of like a polar bear and looks sort of like a grizzly bear, but is neither really. And it's almost, I think this is, many people see this as almost kind of a disturbing image, because the polar bears have often played historically an important role as kind of an emblem of a pristine, untouched, entirely natural Arctic region. What happens when, right down to their DNA, they have aspects of them that are taken from an entirely different ecoregion, and they become, in effect, a different species? So in short, this combination of science and of images may provide all the explanation that we may need to understand why the Arctic is seen as globally significant. But what I would suggest, and I will go further than that, partly because I have another half hour in my talk, so I can't stop right now, but also because that's what historians of science do, that historians of science often follow a familiar trope in their stories. They say, XYZ happened, scientists discovered ABC, and that's how the world changed as a result of these scientific discoveries. And then historians of science will say, oh, it's more complicated than that. Science has to be understood in its cultural and social, economic, and political contexts. And the pathway followed by scientific results to social change is often really rather more crooked than we might imagine, that science works in strange and even mysterious ways to cause changing ideas in society. And perhaps this is also an instance of that. So we need to ask questions like, do in fact images drive policy in this kind of way? Like, images of a disrupted Arctic, can we see this as an instance of images having a transformative impact on people's ideas about the Arctic and about the global environment? Is this an instance of scientific knowledge having a compelling impact on social ideas about the environment, about the Arctic environment, about the place of the Arctic in the global environment? And in particular, how then can we understand how the Arctic, which was once seen as, another otherworldly place, as a remote, pristine, even a hostile landscape, how did it become so central to our concerns and fears about the global environment? If we consider this, first of all, consider a classic image like this that I'm sure everybody has seen a zillion times. The famous Earthrise picture taken by the Apollo 8 astronauts in December 1968, reproduced in countless places, from the Whole Earth catalog to many other sites. And you can imagine, you can easily see, obviously, how this is such a compelling image, especially, I think, the contrast between the lifeless moon in the foreground and the obviously full of life and pulsating Earth in the background. It's making the compelling message that the Earth is somehow special and perhaps unique in the universe, and therefore maybe we really should be a little more careful with it. So it is often taken as an emblematic example of how images have the capacity to change people's minds. And yet, as a number of scholars have argued, this image of Earthrise, of the Earth from space, did not necessarily have such a transformative impact when it first appeared. Or it did have an impact, but only in the context of kind of audiences that were sort of pre-adapted, ready for an image like this. There were ideas in the late 1960s about the global environment already being discussed when this image appeared. In a variety of ways, this image can be seen as influential because people were ready in various ways to be influenced by such an image. And so, in short, science and technology studies scholars who have, like Sheila Jasanoff, for example, Dennis Cosgrove, who have studied the power of images, have made the argument that we have to be wary of assumptions that a single picture, a single image can have sort of a transformative impact on people's minds. And I wonder if a similar kind of thing can be suggested for these images of a disrupted Arctic. Particularly when we consider, as I said, alluded to a couple of minutes ago, about how our historical ideas about the Arctic are so having such contrast to how we understand the Arctic today as a fragile environment within its global context. Images like this from the Maritime Museum in London of two British ships basically locked in the ice for the winter in the early 1850s, capturing the idea of the Arctic as an otherworldly, frozen, a dangerous place, something that is far different from our experience in temperate regions as we can imagine. And it's an image of the Arctic that is still presented nowadays. This is just a still from advertisements for Arctic cruise ships. Again, trying to convey this image of the Arctic. It's an essentially pristine, untouched environment, far away from these notions of the Arctic as being transformed through human activity. Or again, this is a famous painting from the 1860s, a British painting called Man Proposes, God Disposes. It's a rather grisly image polar bearish image, you could say, of polar bears feeding on the remains of, this is an imaginary scene, of course, but feeding on the remains of the Franklin expedition, which was lost in the 1840s. This is like one painter's imaginative take on what happened when these explorers died and basically disappeared somewhere in the Canadian Arctic. The idea that these fierce and ferocious polar bears, hostility incarnate, basically gobbled up the expedition. So conveying a sense that polar bears are not cute and cuddly. We should not be concerned about them. They are dangerous beasts that will readily make a lunch of any unwary humans that come into their territory. So again, a very different view of what the Arctic is about compared to the one that we are so familiar with today of an endangered and fragile Arctic. So the question I wonder about is, how is it that the Arctic then, our views of Arctic made such a transformative shift from viewing this region as hostile, dangerous, remote region to becoming an endangered region that we must safeguard, that we must adopt a protective attitude towards. Now, what I would argue in the rest of my talk is that we need to look at the history of ideas about the Arctic. Of course, as an historian, I would say that, yes, this is where an historian must come into the picture, but that's what the argument I'm going to make. That to understand how we understand the Arctic today, we have to go deeper into the history of ideas, of scientific knowledge, and other forms of knowledge about the Arctic to understand where these images of the global Arctic came from. We could consider, for example, the Cold War period, not the current Cold War period, but the previous Cold War period, the period beginning in almost immediately after the Second World War, by the late 1940s, of heightened tensions and stress between East and West, the East led by the Soviet Union, the West led by the United States. These are classic images of the Cold War, of the Berlin Wall, in this case, of the falling of the Berlin Wall in November 1989, of parades of nuclear missiles going through Red Square in central Moscow. So images, in short, of great tension. The key feature about this episode for my story today is that this was a period not just of heightened tensions, of the building of thousands of nuclear missiles, of the sense of people of these strategic forces being on hair trigger alert, this general sense of fear and potential nuclear Armageddon, but that it was also a time of science. As a number of historians, such as Ronald Doyle, for example, have argued, the Cold War was also the site and the time period of an incredible outpouring of research into the global environment, particularly the physical global environment. And the basic idea here is that it was thought to be a strategic requirement that if military forces were able to operate globally, if the United States Navy was going to sail all the 7 seas of the world, that they needed to have detailed knowledge of the oceanography of the planet. If missiles were going to be able to take off and land and then fall where they were supposed to land, then needed detailed knowledge of the Earth system's gravitational forces and also the nature of the atmosphere. If submarines were going to be operated globally as well, and needed again to understand, have really up-to-date mappings of the floors of the ocean. So in short, there was an immediate imperative throughout this period of the Cold War, in the 1950s and 1960s, to really understand the global environment. One of the major aspects of this was trying to understand the movement of fallout. This is very much the period of nuclear testing in the southwestern United States, in the South Pacific, in the Soviet Union, and elsewhere, as other countries such as Britain and China and the United Kingdom also gained nuclear capabilities. And so there was a great interest in understanding how fallout could spread around the world through the global winds. So in short, there was an enormous effort with vast funding devoted to understanding the global environment as a single integrated system. It was an interesting period in which there was such a close combination between scientific research and new technologies, that new technologies like airplanes and submarines and missiles and so forth called forth new requirements for knowledge. So a very close kind of interweaving kind of coevolution between scientific research and new technologies, with new technologies demanding new forms of knowledge, so new forms of scientific research, and in return, technologies also making possible to do new kinds of scientific research through new kinds of tools, satellites, for example, which made possible remote sensing of the global environment, development of computer models, originally for purposes of weather forecasting, especially for strategic purposes, development of global monitoring networks to measure all aspects of the physical environment. In short, the Cold War was, as I said, a period not just of heightened tensions, but also of an enormous outpouring of scientific research, transforming how science was done, how science was organized, why science was done, and who did it. It created places like the Oak Ridge National Laboratory, which is the image on the right there. The image on the left, of course, is the first satellite Sputnik, launched in October 1957 by the Soviet Union. But the laboratory on the right, that's the Oak Ridge National Laboratory. It became the model of a new kind of a new way of organizing scientific research. I did some of my PhD study at the Oak Ridge National Laboratory. It was a fascinating experience. Believe it or not, there was a major center for ecological research as well. And it's a laboratory that in the single laboratory employed 5,000 scientists. No, it's doing science on a scale far beyond what was experienced beforehand. So in short, the story I'm portraying at this point is about how the Cold War was the site of new kinds of doing science, reconceiving what science itself was, that among other things had the ambition of gaining a knowledge of the entire global environment, because that was seen as an immediate strategic imperative. And this was definitely the case in the Arctic as well. The Cold War was very much seen as a present factor in the Arctic, and the Arctic was seen very much as a strategic frontier, particularly during the early Cold War period. The Soviet Union was just on the far side of the North Pole from North America. There were fears throughout the 1950s that the Soviet Union might launch an attack on North America, perhaps by bombers or missiles or even soldiers. And so there were a series of early warning systems were set up across the northern part of the North American continent to provide early warning of the arrival of the Soviet airplanes or soldiers. The most ambitious such project was the top line there in the map on the left, the distant early warning line. And that's an image on the right of one of the radar stations facing towards the Soviet Union, designed to give early warning of the presence of the incoming arrival of Soviet bombers, so that at least the American president would have a few extra hours to decide what he was going to do about this. So by the early 1950s, the Arctic was, as Trevor Lloyd, a Canadian geographer, described it, it was a highly sophisticated armed camp with a whole network of military bases, of research activities devoted to military needs. In short, the Arctic became a militarized landscape. There was a major focus on trying to work out how to live and work and fight in the Arctic environment. The Arctic seen as a hostile environment, as in effect, a different kind of foe that had to be conquered, that had to learn how to fight against this hostile environment of the cold and ice and permafrost and enormous distances that soldiers and machinery and so forth, airplanes and submarines and all the rest of it, would have to learn to deal with if they were going to operate effectively in the Arctic. There was a pervasive sense that had to catch up with the Soviet Union in terms of Arctic knowledge, because the Soviets were widely seen as the Arctic experts, because they'd been studying the Arctic environment for decades, since the 1930s. So there was, just as periodic concerns during the Cold War about a missile gap, there was also perceptions of a knowledge gap, that our potential adversary knew much more about the Arctic than we did, and that would put us at a disadvantage. So a whole array of scientific activities were developed across the Cold War Arctic. Surveillance of ice, the movement of ice in the Arctic Ocean, for example. That's the map of early surveillance activities, aerial surveillance activities in the late 1940s, of trying to get a sense of just how widely distributed sea ice was in the Arctic at this time. The image on the right, in the center rather, is a weather balloon being launched from what were known as the Joint Arctic Weather Stations, a whole network of Canadian and American weather stations that were set up across the Arctic to try to get sense of how atmospheric patterns created Arctic weather and how Arctic weather then would flow south to temperate regions as well. And the image on the right is one of the tunnels in what was known as Camp Century, a military base in the middle of the Greenland ice cap, where there's an enormous amount of research done in the nature of ice in the Greenland ice cap, with the hope that it perhaps would provide what we needed to know in order to do things such as develop Greenland into a base for nuclear missiles, which was for a period of time in the 1950s was actually considered a serious possibility until it was realized that no, that's crazy. A whole variety of ways having to do with the fact that ice actually moves around; it doesn't just sit still. The overall idea was to develop what was referred to as a total science of the Arctic environment, to figure out how all the different pieces of the Arctic environment fit together and influenced each other. To understand, for example, how to understand Arctic weather, you needed to understand the distribution of sea ice on the Arctic Ocean. You couldn't just look at the weather itself, but you had to understand how the distribution of ice and snow really mattered to what future weather would be. So in short, the Cold War really had a formative influence on our ideas about the Arctic and the dynamics of the Arctic and how the Arctic fit into the global environment. That this knowledge about the Arctic was seen as a tool of the military, as something that was a strategic imperative. And so in short, a lot of our ideas about the nature of the Arctic environment that we still are familiar with today actually date back to research done in the 50s and 60s and 70s that had an immediate strategic imperative, not focused on, say, concerns about our impacts on the global environment, but more concerned with trying to figure out how to operate in this hostile Arctic environment. One thing that this Cold War Arctic research especially had, one aspect of its influence was especially in defining various ways in which the Arctic was in fact a distinctive environment. I mean, it was already known to be a place where there are many challenges that were unlike those found anywhere else. You know, the challenges of sea ice, which seagoing explorers had been grappling with for centuries. The challenges of permafrost as well when it comes to traveling across the land. The enormous challenges involved just in the great distances involved in the Arctic as well. But with the Cold War as well, new ways in which the Arctic was distinctive kind of started to come into the foreground. It started to be realized, for example, that there were distinctive challenges with respect to nuclear fallout. That, you know, the fundamental assumption was that during the early days of the nuclear era was that the Arctic was probably more or less insulated from the nuclear fallout. It was so far away from where nuclear weapons are being tested that it would probably stay more or less pristine. And they discovered in the late 1950s that in fact, Inuit had even elevated concentrations of radioactive materials in their bodies, even more elevated than those folks who were living much closer to nuclear test ranges in Nevada and elsewhere. And eventually worked out how there was something, it had to do with the distinctive ecology of the Arctic tundra. Lichen, a widespread form of vegetation on the Arctic tundra, is really good at accumulating materials from the atmosphere, including nuclear fallout. Caribou like eating lichen in large quantities, and so the caribou would accumulate large quantities of nuclear fallout. Caribou is an important food source for Inuit in much of the Arctic, and so they would then, the fallout, radioactive elements would continue up the food chain from lichen to caribou to humans. And so it became kind of an early indication of how, in the context of the changing global environment, the Arctic was perhaps sensitive or vulnerable in distinctive ways. Another way in which during the Cold War era was starting to be recognized that the Arctic was perhaps distinctively vulnerable to human-caused change was a realization that if, as was starting to be imagined by the late 60s, early 70s, that rising carbon dioxide and other greenhouse gases were going to have a warming effect on the planet. And this started to be talked seriously about in the late 60s and early 70s, and that's when first kind of modeling experiments were being done to try to figure out how to model the effects of changing carbon dioxide in the atmosphere. It was very quickly realized that the polar regions would be melting more, be getting warmer more quickly than other parts of the world. So like this, for example, this is just an early output from a model prepared in the early 1970s, 50 years ago, showing how it's a very primitive model that you could, you could run a model like this. You wouldn't even need a computer the size of your phone to run a model like this, but it was showing results that are being now demonstrated in far greater detail with the far more sophisticated computer models we have now, showing that the polar regions, especially the Arctic, would likely warm more quickly as greenhouse gases accumulated in the atmosphere. So identifying another way in which the Arctic could be distinctively vulnerable to global change. So in short, what was happening during this period, during the Cold War, was an emerging understanding of the Arctic as a distinctive environment, not just in terms of the ways in which people have been familiar with for centuries of ice and permafrost and so forth, but in terms of ways that went along with the way in which people were starting to realize humans were having an impact on the global environment. Fallout, for example, and the prospect of climate change as well. That in the global context of the flows of contaminants, such as nuclear fallout, of the movement of air patterns generally, and of how these were tied in various ways to strategic power, that the Arctic had to be understood as a distinctive environment. I'll just pause here. Now, by around the late 1960s, though, the Arctic was becoming much less of a Cold War frontier. Tensions were arising in other parts of the world, like Vietnam, the Middle East, Berlin, and so forth. The Arctic was becoming less seen as a real tension spot between the Soviet Union and the United States. And instead, there are other ways in which people were getting interested in the Arctic. And in particular, the Arctic was being seen increasingly as an energy frontier. Oil was discovered in 1968 in large quantities on the Arctic Alaska North Slope, and there's interest in building a pipeline, either building a pipeline across Alaska to carry the oil to southern markets, or perhaps to send super tankers across the Arctic Ocean to carry the oil south. So there was an early experiment in 1969 with the Manhattan, the ship on the right, an ice-reinforced supertanker that was hoped could basically blast its way through the Arctic sea ice to carry oil to the south. And for a variety of reasons, it was concluded that it was far more feasible to build a pipeline. So this experiment of using supertankers was not proceeded with further. Instead, pipeline was built from across Alaska. And in general, there's an acceleration through the 1960s and 1970s and into about the early 1980s of energy exploration and development in both Alaska and northern Canada. This is not just an Arctic phenomenon. I see this interest in Arctic energy emerging in the 1970s, especially at the time of the oil crisis in 1973, as part of a global search for energy that energy companies, Exxon, Shell, and all the rest of them, they advertise themselves as global companies willing to go wherever on the planet energy was to be found, in the darkest jungles, in the most remote deserts, in the Arctic, that energy was a global commodity and the Arctic was simply part of that global economic imperative. There were a lot of close ties between the environmental expertise that was developed during the Cold War era and Arctic energy exploration. It was realized that a lot of the same techniques you could use to enable military forces to operate in the Arctic could also be used to make it possible for oil companies to operate effectively in the Arctic. And in particular, ice itself, seen as a chief obstacle to extracting oil and natural gas from the Arctic, and it became the focus of an enormous amount of engineering research. Ice itself became seen as an object to be re-engineered, to be made feasible, to be manipulated, to become less of an obstacle, to extracting oil and natural gas, and in fact more of a tool that could be used in various ways to operate to extract oil and natural gas from the Arctic environment. One of the the culmination of these kinds of ideas about re-engineering the Arctic and re-engineering ice to make it amenable to the exploitation and removal and extraction of energy was ideas that are emerging, like as represented in this advertisement from Look magazine from 1962. You see what was happening here. This is the Humble Oil Company, which became a unit of Exxon eventually when Exxon was created. And they're boasting about how each day Humble supplies enough energy to melt 7 million tons of glacier. It's sort of a statement that nowadays in 2022, we might feel a bit of a shiver towards. But in 1962, 60 years ago, that was very much a boast. Just showing what kind of capabilities we have to transform nature as part of the search for energy. And this whole idea that melting ice, perhaps getting rid of the ice that was infesting the Arctic Ocean, could open the Arctic Ocean to energy, the energy economy, the energy industry, and enable the Arctic to be incorporated within the global energy economy. And that was seen very much through the 1960s as a matter of progress. So these are ideas about transforming the Arctic, making it part of the global energy economy, that naturally enough, by the late 1960s, were generating a reaction. This is the time in the late 60s when environmental concerns were really becoming prominent. And the Arctic was becoming part of that. And people were even kind of recoiling against this idea of simply seeing the Arctic as an energy frontier to be dominated and melted if necessary in order to become part of the energy economy. And so there were increasing concerns as part of the larger emergence of environmentalism in Western society in the late 60s and early 1970s, concerns about the status of the Arctic environment as well. So concerns about the state of the Arctic tundra. It was recognized very early on, simply through practical experience, that the tundra seemed to be unusually vulnerable. That if you drove, for example, a single tracked vehicle across the tundra, that would basically break the protective layer, protecting the permafrost from melting. And over a period of a few years, you would go from a single set of tire tracks or tractor tracks to a big gash across the tundra landscape, like you see on the left here. And so there's an increasing kind of discourse or language about viewing the Arctic as a distinctively fragile space, as these various quotes kind of illustrate that these are quotes that stand in for many comments during the late 60s and early 70s of a new view emerging of the Arctic as not, as I said, a strategic frontier or an energy frontier, but it's a fragile landscape to be safeguarded. The middle quote there is as one illustrative example. Prime Minister Pierre Trudeau, the Prime Minister of the day, father of current Justin Trudeau, is stated in the Canadian Parliament in October 1969, talking in the same kind of language that was being widely invoked at this time, this notion of a peculiar ecological balance, precarious existence of Arctic ecosystems and so forth. And as well, that the Arctic was potentially an outdoor laboratory, a fragile laboratory. It could be a place where scientists could develop new knowledge, but could also play an essential role in protecting this fragile environment. A lot of these ideas came together and were expressed at a pivotal conference that took place in Edmonton, Alberta, in October 1969, became known as the Tundra Conference, and it brought together scientists, journalists, political figures, people from the energy industry and so forth, and who basically put on the map various ideas about the tundra as a distinctively fragile environment. That image there is just this is a bit of an instance where I just combined a little bit of Arctic history with a little bit of family history. That's going through my father's papers a few years ago and happened to come across this pass. And I didn't know at the time, but that he had actually attended the Tundra Conference in 1969, and this was his press pass. He was at the time working for the Canadian Broadcasting Corporation. So that was, I didn't have a chance to ask him about his attendance at the Tundra Conference. I wish I had at the time, but it's funny to discover this press pass in his papers. So at any rate, the idea of the Arctic as a distinctively fragile environment was becoming really widespread by the early 1970s. And this was also tying into changing ideas about the global environment. A key part of environmentalism of the early 1970s was the idea of the global environment that was emerging. And it was an idea that emerged to a large extent out of ideas that have become already current during the Cold War. The ambitions during the Cold War era to subject the entire planet to strategic surveillance was then converted into a view of viewing the entire Earth as precious and fragile. And so this is part of the preparation that made views of the Earth from space, like the one on the right there, particularly influential, because people were already accustomed in a strategic context to think about the global environment, that various Cold War strategic environmental science activities were kind of redrawn and reconceived to fulfill various environmental objectives. Studies of the atmosphere for strategic purposes, for example, were kind of re-engineered into studies of the changing global climate. Ice core studies, which were done originally to make it possible to generate the knowledge for engineering ice, was instead redeveloped as a basic way of studying the history of contaminants. Ice cores, especially taken from the Greenland ice cap and from certain glaciers and from the Antarctic, provide an absolutely precious record of the history of contaminants in the atmosphere, often going back hundreds of thousands of years. So it was various ways in which Cold War strategic global environmental science was kind of, as I said, re-engineered, provide a foundation for emerging concerns about the impacts of human activities on the global environment then. I'll just mention very briefly, I know that I'm starting to exhaust your patience with respect to time, so I'm going to expedite things along a bit, but just to note how Rachel Carson in Silent Spring, if you've read Silent Spring, you may recall her very first chapter, A Fable for Tomorrow, where she described how a healthy American town became suddenly unhealthy as this mysterious white powder descended from the atmosphere. People became sick, birds died, animals died, and so forth, and drawing a conscious connection throughout Silent Spring then between the specter of nuclear fallout and other kinds of fallout, and particularly the fallout represented by toxic contaminants, including pesticides such as DDT. And so various ways, in short, in which concerns about the global environment during the Cold War era that were to a large extent framed in terms of nuclear fallout became kind of generalized through the work of people like Rachel Carson to a general concern about the impacts of humans generally, not least through our global production and spread of toxic contaminants, to a larger concern with our impacts on the global environment then. And this was certainly the case in the Arctic as well, so returning to the Arctic again, that it became realized in part in the aftermath of Silent Spring that the Arctic was also part of a global chemical economy. Inspired in part by Silent Spring, scientists traveled north to identify the presence of DDT and other pesticides in the Arctic environment, so finding various ways in which the Arctic was no longer so pristine. So there was an emerging sense then by the late 60s, early 1970s of the Arctic as particularly vulnerable to human activities. And this was a sense that was weaving together a variety of different ideas. From the Cold War period, the ideas about the global environment, ideas about the Arctic as part of a global economy as well, whether of the energy economy, production of energy, or about part of the global chemical economy, in this case of toxic chemicals flowing north and contaminating the Arctic. And then also how the Arctic was becoming incorporated within ideas about environmentalism as well. Ideas that, that Rachel Carson, for example, distributed to a global audience were becoming expressed in the Arctic as well. But there was a really important dimension of ideas about the Arctic that was just becoming politically visible as well by the late 60s and early 70s as well. And that was a very different view, a very different way of understanding the Arctic environment that was invisible for many years, but became, starting in the 1970s, increasingly significant in a variety of ways. And I'm talking about the Arctic as an indigenous space. As Inuit, the original inhabitants of the Arctic, started to make their voices known in political and other contexts, they started to challenge dominant ideas about ways of understanding the Arctic environment, considering, for example, different ways of understanding the nature of ice itself. Like, should ice be understood as it's represented on the image on the left, of a global view of looking at the ice from several thousand miles out in space and looking at the trends in the entire layer ice cover of the Arctic Ocean, so understood in kind of a macro global view? Or should ice be understood as an intensely local phenomenon being experienced by Inuit hunters who face ever increasing anxiety about whether the ice that they had once assumed was stable was in fact perhaps unstable, unpredictable, changing in ways that were contrary to their daily experience? So understanding the Arctic environment, is it a global environment, or is it in fact an intensely local environment? More generally, Inuit posed today a challenge to understanding our fundamental assumptions about nature itself. One of the basic kind of ideas about nature that we inherited as part of Western society is the idea that there's nature over here and culture over here, and that these are separate, and that we can look at just nature. We can ask scientists to study nature, and then we can ask humanities folks and so forth, poets and all the rest of them, to study society, and that we don't necessarily need to consider them together. Inuit, on the other hand, like other indigenous peoples, see this notion of nature-culture dualism of separation as simply inconceivable. That the concept of sila, which is so familiar to Inuit people, see it's a way of expressing the idea that the Arctic is a natural environment. It's also a human environment. It incorporates physical phenomena. It also incorporates moral values and every other aspect of society, that you have to consider the Arctic, in short, as not just a natural space, but as very much intensely a human space as well. So directly challenging fundamental assumptions that we have about nature and that we have so readily applied to the Arctic as well. Which then led to ideas, as Inuit have expressed, about the relationship between the Arctic and the global environment is not just a matter of physical science, of climate models and measurements and so forth, but there's issues about justice here, about the idea that the Arctic environment is changing as a result of modern industrial society. People in the Arctic are being affected by that, who have nothing to do with that industrial economy. And so that raises basic issues about justice. As Sheila Watt-Cloutier, a prominent Inuit diplomat, has argued that global climate change, as it is experienced in the Arctic, endangers the Inuit right to be cold, a very distinctive Arctic framing of human rights, that we can think of human rights not just in terms of freedom of speech and of religion and of conscience and all the rest of it, but also the right to be cold, which is a particularly regional framing of environmental justice then, that challenges our fundamental ideas about even what a human right is, I would think. These ideas about Arctic environmental justice, the right to be cold, about casting away this nature-culture dualism and so forth. It's something that has gained a lot of attention over the last few years, but it's also been something that's been building for several decades. Just to briefly note that in terms of the historical context of the formation of the idea of the Arctic as an indigenous space, there's a substantial history extending over several decades of Inuit and other Arctic indigenous peoples asserting political claims to the landscape through creation, as in this case in Northern Canada, for example, of a variety of territories, the Nunavut territory, much of Northern Quebec, the Inuvialuit settlement region in the Northwestern Arctic, a variety of other regions as well, where indigenous peoples share with state authorities authority over the landscape. The Mackenzie Valley Pipeline Inquiry in the 1970s was a really important chapter in the assertion of distinctive indigenous ways of knowing as well, asserting as well that the North should not simply be understood as a resource frontier, as a place where useful energy can be extracted, or as a strategic frontier, but it should be understood as a homeland as well. So an entirely different way of framing the Northern environment. One of the really pivotal, and I am getting close to the end of my talk here, I'd be encouraged to know. One of the really pivotal events in terms of the framing in a global context of the Arctic as an indigenous space has been the indigenous experience, Inuit experience with contaminants. You know, it is a basic feature of the Inuit food economy to the present day, that country foods such as seal, walrus, beluga whales constituted a really central part of the diet of people in Inuit communities. It's also a distinctive feature of these species that they are very fatty, fat-rich. That is an important part of the diet. But these very fatty creatures like seals and walruses and beluga whales also share the capacity to accumulate substantial quantities of toxic contaminants. The contaminants, the natural order of things, they accumulate preferentially in the fatty deposits of certain species. And that has been the experience that Inuit have had as well, that starting in the mid to late 1980s, it became realized that that contaminants are present in the species that Inuit consume, and that they are present in the bodies of Inuit themselves, that persistent organic pollutants had traveled often thousands of miles into the Arctic and were resulting in Inuit having concentrations of contaminants in their bodies often far higher than those of people living much closer to the sources of industrial and agricultural contaminants. The striking thing that happened in the late 1980s, which said an awful lot about how Arctic knowledge was thought of at this time, was that in the late 1980s, when scientists were first starting to discover that there were dangerous levels of contaminants in Inuit bodies, is that no one told the Inuit themselves. Instead, scientists basically talked to the news media, and the news media, such as the front page of the Toronto Globe and Mail, Canada's national newspaper, reported and gave a great deal of prominence to the discovery of elevated levels of contaminants in Inuit bodies, as in this newspaper article from December 1988. The Canadian Broadcasting Corporation picked up this news and reported it on their northern service. Inuit learned that their bodies contained potentially dangerous levels of contaminants by hearing about it over the radio in the news. And you can imagine the reaction. If you live thousands of miles from any industry, really, any sources of contaminants, and you hear on the news, in the morning news, that your body may contain dangerous contaminants and they're coming at you, into you, by way of the food that is absolutely central to your ways of life. You know, as Sheila Watts-Cloutier, the Inuit diplomat, described, that it just caused such a level of shock and confusion and frustration and anger in Inuit communities that had a whole array of political consequences in terms of insisting on that Indigenous peoples, including Inuit, had to have a larger role in understanding the Arctic global environment. That if it's true that Inuit were being poisoned, then Inuit had to be there to do these studies, to understand just what was going on here, that they were not going to tolerate simply being told that they were being contaminated by scientists who were speaking in scientese and not explaining these things to the Inuit themselves. Particularly given, as I said, that these country foods, beluga whales, walruses, and seals and so forth, are totally central to Inuit ways of life, not just as food, as nutrition, but as the basis for community cohesion, for sharing, for daily practices of hunting and so forth. As this Inuit elder said, that he said, contaminants do not affect our souls. Avoiding our food from fear does. And the ultimate upshot from this experience with contaminants was that it led to changing ideas about how you do science in the North. That it led especially to the idea that contaminants research in the Arctic had to be done collaboratively. It simply couldn't be done by scientists traveling north, doing their studies, collecting samples and all the rest of it, then heading back down to their universities or labs in the south, writing up their papers and publishing in scientific journals. That the contaminants research had to be done in collaboration with communities in the Arctic, and that the communities had to play a central role in determining the research practices, the questions the scientists were going to ask, and how those results were going to be communicated. So in short, what became central to our ideas about the Arctic in the global context was the different way of doing research, of connecting research to community priorities in ways that would more effectively meet the requirements of Inuit communities. And this became kind of a central feature of Arctic knowledge more generally that's expressed in these two badges here. One is from the International Geophysical Year, way back in the late 1950s, basically expressing the idea of studying the entire globe, this idea about the global environment that was becoming quite current during the Cold War. And then the more recent International Polar Year, 2007, 2008, again, a view of the globe, but with the incorporation of a human figure as well, to make the argument that if you are going to study the polar regions, including the Arctic, you had to include humans in your research. This has been an argument that Inuit people and Indigenous people in the Arctic generally have furthered in a variety of contexts through their participation in the Arctic Council, for example, which is a major body for circumpolar governance. In Arctic peoples asserting that they can serve as distinctive witnesses of global change through their daily activities, through their practical, environmental, political activities, such as their opposition to oil drilling in the Arctic National Wildlife Refuge, going right up to the present day, and through their general argument that to understand the Arctic, you could not simply consider knowledge as being in a separate, isolated category, that you had to combine knowledge and experience in the landscape and the values you attach to that landscape in various ways, that you had to consider, therefore, that science is not the only path to understanding the Arctic. There are other forms of knowledge as well, that decisions about the Arctic environment could not simply be understood as having scientific answers, or being guided by scientific advice, but they were essentially political issues and therefore required collaboration within communities, and that communities in general and the knowledge held within communities had to become a central feature of Arctic environmental affairs. This is just kind of represented as well by a whole outpouring of research, community-based research that has emerged over the last 10 or 15 years or so across the Arctic. And the basic idea here is simply how the Arctic has become kind of one of those central frontiers in experiments and trying to develop community-based research in really interesting ways that perhaps folks elsewhere can learn from. So to sum up then, what I'm describing here is kind of the crooked path. I describe it as the crooked path to the global Arctic, that we understand the Arctic as distinctively vulnerable to global change. But there has been nothing like a straight path of simply the steady accumulation of scientific evidence showing how the Arctic has been warming more quickly or there's other consequences of global change for the Arctic environment, but that it's been a fairly crooked path. There's been a weaving of priorities, of forms of research, of ways of thinking, of ideas about place that have taken elements from the Cold War era of viewing the Arctic as a strategic frontier between the Soviet Union and the United States, as viewing the Arctic as a resource opportunity, as a fragile ecosystem, and as an indigenous homeland, weaving aspects of all those views of the Arctic into our understanding of the Arctic as a distinctive place within the global environment. Another essential feature of this history that I just wanted to note too is the central significance of surprises. That again, just to underline how this is not a story about the steady accumulation of knowledge. Often the most influential aspects of this history of knowledge have been the absence of knowledge, the realization that there's stuff we don't know about the Arctic. And so therefore is calling attention to the fact that if we don't know things, if we're surprised by what we observe, like the heavy accumulation of nuclear fallout or of organic pollutants or of accelerated warming, that those are signs that there are sharp limits on what we know about the Arctic. And therefore that has implications for how we should behave towards the Arctic. And finally, that there's a variety of new ways of thinking about knowledge itself that have emerged in the Arctic and become part of the global Arctic as well. These notions of collaboration, of linking local experience with global perspectives in various ways, of finding ways of respecting the fact that knowledge comes in many diverse forms of experience. Finally, as the fanfare announced, a few key aspects of ideas about global knowledge generally, because I think what we've learned about the Arctic has implications for how we understand the global environment more broadly. One of the things that we often see in presentations about how knowledge about the global environment has emerged, so we see that in a very kind of macro scale, like how knowledge about the entire planet has emerged over time, whether views from space or global climate models or what have you. But it's important to note too how global knowledge is situated in specific regions. We have to connect our knowledge of the globe to knowledge that's accumulated in particular places. It could be the Arctic, or it could be the Climate Change Institute, say at the University of Maine, countless other local places where local knowledge has been generated and been converted into global knowledge. Secondly, that global change, as I tried to stress, is not just about physical changes, but it's also about a whole array of social and cultural factors that shape our ideas about particular places, and also about how those places are connected to the planet. And then finally, I end kind of with a question or a problem about how we ourselves, if I imagine most or all of us in this room are people who are not situated in the Arctic, yet perhaps have kind of a concern for polar bears and the state of the Arctic environment and so forth. And how should we think about that idea? How should we think about the Arctic? Those of us who don't live in the Arctic and may never visit the Arctic. In short, how do we speak about a place that is not one's own place? Quite a number of years ago, the eminent American environmental historian William Cronin wrote a famous essay called Getting Back to the Wrong Nature. And the basic argument he made, which became very controversial, this was in the mid-1990s, was the idea that the fixation that many environmentalists have with preserving pristine nature, particularly wilderness, is important, but also may be seen as a way of absolving our responsibility of places that are closer to us, the places that we actually live, and that in expressing concern for pristine wilderness out in the back of beyond is a way of turning our gaze away from the things that we actually have control over and that we actually influence in the local places that we actually live and have responsibility for. And so I wonder if the presence of the Arctic in contemporary global discourse and polar bears and all the rest of that, as important as the Arctic is, and it is absolutely essential, obviously, is it also become so widely invoked because it's a way of thinking about something other than our own responsibility for the places in which we live ourselves. And so I'll just leave you with that thought. And that's it. Thank you so much for your attention. I just end with an image here of the frozen Arctic wasteland of Trent University in mid-January. Yes.
So, in your focus on the Cold War period, was from a Western perspective, what was the Soviet Union, what did the communists think about the Arctic in the Cold War period? And also, this idea that the Arctic was distant and needed to be, the humans to be far away from the Arctic, was it a way to perhaps construct the idea so that the Soviets would not access the Arctic. It's a way to keep them away, type of excuse.
Very interesting question. Maybe I'll just repeat the question because I imagine it wouldn't have been picked up by this microphone for anybody listening remotely. But your question is about, given that I presented especially the Cold War perspective from the point of view of the West, how did the Soviet Union view the Arctic during the Cold War era? And then how did we view in terms of like how we thought whether the Soviet Union might be excluded from the Arctic during the Cold War period through the knowledge that we were gaining? And those are a really interesting kind of set of questions. Certainly the Soviet Union throughout the Cold War era saw Arctic science as a major priority, not just as a strategic priority, but they also had very consciously the objective of developing their own Arctic region as an economic landscape. They saw a whole array of useful resources of oil and minerals and so forth that could feed their economy. And so they put enormous investments, creating entire Arctic cities focused on scientific research, far beyond even what was being invested in the West. So they had, a lot of the same scientific priorities that we see here in the West. Like they had missiles, fleets of missiles as well. So they were concerned with getting a grasp of global fields of gravitation and things like that you needed to know where to be able to target missiles accurately. And they had an interest in running their submarines under the sea ice and those kinds of things. So they engaged in a lot of parallel activities. But certainly they had, I think they had a much more conscious idea in their Arctic research of seeking to actively colonize the Arctic regions of the Soviet Union, because in North America, Cold War research was devoted towards enabling military activities to proceed effectively in the Arctic region, but it wasn't seen as part of a larger objective, say, of developing large populations, of, say, encouraging people to move into the North in large numbers. Whereas in the Soviet Union, they very much worked more actively to incorporate during the Cold War era the Arctic into the Soviet Union society. So they provided, for example, a lot of financial incentives and extra pay and that kind of thing to encourage Soviet citizens to move into Arctic cities. So there's that kind of aspect. When it came to like in terms of the idea of excluding Soviet Union from the Arctic regions, that was less a priority because the Arctic Ocean was to a large extent seen as a kind of like a global commons. The boundaries between countries in terms of like the territorial responsibility for sections of the Arctic Ocean was really poorly defined. It's only now in the last few years being more precisely defined where exactly how the Arctic Ocean is going to be divided up into the responsibility of different circumpolar nations. So it wasn't, I would say, an effort of exclusion, but more simply the idea of trying to gain the capability to detect the Soviet submarines or ships or whatever, or airplanes, wherever they happen to be, given that they were going to be there. And so they wanted to understand how to detect submarines under sea ice, say, or develop advanced radar and so forth to be able to track Soviet aircraft for as early as possible and that kind of thing. Okay. Yeah.
So I'm curious, based on the data you showed us about sea level rise and warming in the Arctic, would you predict that it stays on that upward trend? And if that is the case, what do you think that means for future oil extraction?
Mm-hmm. Yeah, that's a really interesting question. There's several different strands there that certainly, the current forecasts now are that sea level rise is going to continue, of course, and likely more quickly than is generally projected. That historically, over the last couple of decades, the Intergovernmental Panel on Climate Change has tended to be fairly conservative in its projections of sea level rise, and it's thought that likely the projections will continue, perhaps we're talking somewhere between 1 meter and 3 meters by year 2100, something like that, very roughly. Coming as in part as a result of the melting of the Greenland ice cap and the Antarctic ice cap, and also as a result of thermal expansion of the oceans. With respect to consequences for like opening up the Arctic Ocean as more of the ocean becomes free of ice, and therefore, in theory at least, more accessible to oil drilling ships and extract oil energy exploitation generally. It's been presented that, like it's been often argued that yes, there's sort of a deterministic relation of less ice, therefore you'll have more opportunities for energy extraction. But the opposing argument can be made as well, is that as it's going to be a long time before there's no ice at all in the Arctic. So even as the sea ice is melting away persistently year by year, that can even create more hazardous conditions rather than less hazardous conditions from the point of view of industry, because you've got just a zillion more glaciers and loose ice moving around in unpredictable ways that can be more dangerous than the previously homogeneous but more or less stable and kind of less mobile sea ice that was there previously. In short, the sea ice is becoming less predictable. And if there's one thing industry does not like in the environments it works in, it does not like unpredictability. So I would think that for a variety of reasons, it's been noted that like the US Geological Survey has suggested on the basis of their studies, there are really significant fractions of the global stocks of oil and natural gas still present in the Arctic. But I think it's unlikely those are going to be extracted on any time frame that's realistic to us. Partly in terms of just the physical matter issues that I just described, but also as a political issue. There are heavy political costs associated with oil companies being involved in the Arctic, simply because of the Arctic being of such wide concern. That's an important dimension I didn't get into, but we could also note that. But that's why, for example, major oil companies have declined to buy leases in the Arctic National Wildlife Refuge. There may be profitable oil there in terms of dollars and cents, but they just don't want to pay the costs of becoming noteworthy as despoilers of the Arctic with all that comes. There's just too much reputational cost associated. So I think there are environmental challenges to exploiting energy from the Arctic, but the political challenges are even greater.
Any questions? There's a reception after, so you can ask your questions then. I'm supposed to close things out with a presentation. You have a framed certificate that we get to present today to our speaker, and well, the fun part, there you go. So please join me in thanking Professor Stephen Bocking for his talk here today. And if you're a student and you want to ask Professor Bocking a question, there's going to be a meeting with students at the Mitchell Center, Norman Smith Hall, at 3:30 in room 105. So if you want to come, grad student, undergrad, what have you, and ask your question in person, just chat, but whatever, that's 3:30, room 105 in the Mitchell Center. So thank you, Stephen.
Great. Well, thank you
So much.